What is the smallest three-digit number that can be written as the product of two consecutive positive integers? So we're looking for a three-digit number. So first, let's just figure out what would happen with consecutive integers. So 1 times 2 is 2. So that's obviously not even close, because that's not a three-digit number. So let's choose something bigger. Say two consecutive integers, 3 and 4. What's their product? 12. Okay, now we have a two-digit number. So we're getting bigger. Let's see, how about 8 and 9? What does that do? That's two consecutive numbers. Their product is 72. Okay, we're getting bigger. Let's see, 9 times 10 would be the next one. That's 90. How about 10 times 11? That's 110. And that is the one that would be, I guess, the smallest three-digit number that can be written as the product of two consecutive positive integers. In my truck, I'm moving a rectangular solid whose volume is 105. If the length of each edge is prime, what is the total surface area of the rectangular solid? Well, let's say this is the rectangular solid. The length times width times height is the volume. And they're telling me that's 105. Okay. And they're saying that all three of these are primes. So I'm pretty sure I could factor out 105 into 3 primes. It'd be 5. And that would leave 21. And the 21 can be broken up into 3 and 7. So there we go. So that's the prime factorization. I guess this is obviously not drawn to scale, but the length, I've labeled it as 5, the width as 3, and the height is 7. Now the surface area, that would be 2 times the height times the length, let's put this in brackets, plus the height times the width, plus the length times the width, right? And that looks to me, you can just fill in the numbers here. The height is 7, oh sorry, yeah, the height is 7, the length is 5. The height is 7, length is 3, the length is 5, width is 3. And then when you crunch out these numbers, you will get 2 times 35 plus 21 plus 15, and that is all going to be 142. If x is t squared minus 4t and y is 1 over t minus 2, what is the value of x when y is 1 over 3 root 2? Well, we could do the substitution. Y is that, so substitute that into here, and then calculate for t, and then substitute that into here. But that's going to be very time consuming. Let me just see if I can get this. We just look for t squared minus 4t, right? Yeah, I think that should be a little bit easier to get using this. So let me see. If y is equal to 1 over t minus 2, let's cross multiply. That means t minus 2 is equal to 1 over y, right? And then t minus 2, well, y is this. So 1 over y would just be the reciprocal. Aha. And I think now it's going to be much easier to get this guy up here. If I square both sides, then I'll get t minus 2 times squared, and then 3 root 2 all squared. And that looks like 9 times 2, which is 18. And then if I expand this, it'll be t squared minus 4t plus 4. Ah, there we go. T squared minus 4t is 14. And that is, I think, the much easier way of doing this question rather than the substitution and algebra. That would be very time consuming. What is the minimum value of sine 2007x times cos 2007x? Minimum value. Okay. Well, one of the trig identities that immediately comes to mind, identities, is the one that says that the sine of 2 theta is equal to 2 sine theta cos theta. Because it kind of looks like that, right? So in this case, what we'll do is we'll let 2007x equal theta. So that means this would be 2 sine 2007x times the oops, I forgot the x, times the cos of 2007x, and then that would be sine of 2 times theta, which in this case would be 4014x. Yeah. Let me see if that's right. I think so. Sine of 4. Yeah. And then therefore, sine of 2007x times cos of 2007x would be the sine of 4014x all over 2. You got it? Okay, so that makes it a little bit easier because this guy right here, the sine of anything, so the sine of anything, let's just say theta, as you may recall, is always between 1 and -1, right? If you remember the graph of sine, if this is the sine of theta, if this is, let me do that properly here. If this is theta and this axis is the sine of theta, the graph is like this, right? You guys remember, it just keeps on going. And the top corresponds to 1 and the bottom corresponds to -1. So the sine of something is always between 1 and -1. Now they're asking for the minimum. So the minimum value, min value of sine theta is -1. That's the lowest it can be. So just substitute that into here. So that would be -1 over 2 is equal to the sine of 2007x times the cos of 2007x. And that's pretty much what they're looking for. So -1/2 is the answer. A function f will be called repetitive if there are at least 2 different values of x in the interval x is between 0 and 1 inclusive, for which f at x has the same value. What are the real numbers b for which f at x is equal to x squared plus bx plus 3 is repetitive? Okay, so let's see if we first even understand this question. At least 2 values of x for which is, okay, so this is obviously a quadratic. So a quadratic is something like this, right? I'm just giving an example to try to understand this question. And let's just say that is f. And it's repetitive if there are at least 2 different values of x. So this is x, and this is, I guess, f at x. 2 different values of x in the intervals 0 and 1. So this is 0, and let's say, I don't know, let's say put 1 out there, for which f at x had the same value. Okay, so let's say we have this value and this value. They would correspond to something, whatever they correspond to do. Let's say 0.2 and 0.8. And they will both have the value, I don't know, let's just make something up, 0.3. So that's just an example of what I think the interpretation is of this question. Okay. All right, so then we have been given an actual f at x, and they're trying to ask what is the value of b. Okay, so let's see what we can do. F at x is equal to x squared plus bx plus 3. And what else do we know? What do we have to do here? I think we have to complete the square. Complete the square. And it basically is where you make f at x in the form ax minus h squared plus k, where that will tell you when x is equal to h, f at x is equal to k. So the graphic would be something like this. If we have x and f at x, when x is equal to h, so if this is h, x is equal to k, and I guess in this case, since this is positive, it's going to open up, and this is the k. So it helps me figure out the minimum or maximum. But in order to get it into this form, we have to complete the square on this guy. Okay, so let me go through that. So complete the square. What you do, you take this number, which in this case is b, and take half of it. So let me just do it on the side here. That's b over 2. And then you square it. So that would be b squared over 4. And then you add that and you subtract it. So add it, b squared over 4, and subtract it. Because you can't change the equation, but you can do that because that hasn't changed the equation. Now you say, what's the point of doing that? Well, that allows you to factor. These three terms now factor beautifully into x plus b over 2 all squared. And then the rest, which I'll just write as 3 minus b squared over 4, that kind of, goes in this outside of the bracket. This allows me to figure out the max and min. So in this case, it would be that when x is equal to minus b over 2, f at x would be equal to 3 minus b squared over 4. So the same kind of story here. When x is equal to that, we have a value that is most likely the min because the coefficient here is 1, and 1 is obviously a positive number. So let me just see if I can draw that, draw it properly here. So that means, like, for example, if, and I have no idea what this looks like, but let's say it looks something like this. Then that means that, and this is x, and this is f at x. So that means that when, in this case, x is minus b over 2, so this is minus b over 2, this point right here, this corresponds to the 3 minus b squared over 4. Okay, now that graph is just, I'm just giving it as an example. It could be, it could not be, it wouldn't really necessarily look exactly like that, but I'm just giving an example. Okay, so now what do they want us to do in this question? Find all real numbers b. Okay, so what do we know here so far? We don't know much, do we? We have this piece. Okay, I got it. X is between, that's going to help us. X is between 0 and 1. Okay. So X is between 0 and 1. Okay, and then those two things will allow me. So let me just put that here. X is between 0 and 1. Now these two things are going to allow me to figure out a range for B. Okay. So if, so X is between 1 and 0. So I'm going to try to put B in there. So let me just, if X is equal to minus B over 2, then I put that in there, minus B over 2. But they just want B, so let me first multiply through by 2. So it'll be 0 minus B and minus just positive 2. And then multiply through by negative 1. Well, is this less than or equal to? Yeah, less than or equal to. Less than or equal to. So then that would be B greater than, multiplying through by a negative, right? So minus 2 and less than 0. And I believe that should be the correct answer. Our design team drew all 48 line segments that connect 6 points on one side of rectangle R to 8 points on the opposite side. In at most, how many different points inside R can these 48 line segments intersect? Okay, so we've got all this, right? So we've got 6 and 8. So let me just draw that here. So 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay, that I'm assuming they're all equidistant. And then 8 on this side. So there'll be 6 in the middle. So 1, 2, 3, 4, 5, 6. Okay. And then basically, what are they trying to do? And how many and how many different points can inside R can these 48 line segments intersect? Okay. So the total number an example. Let's choose some points. Let's choose this guy, this one, and this one, and say this one. And then let's draw lines in between. So this from there to there, and from there to there. So this, obviously, is a point of intersection, this green dot that I drew. Now, how did we get that? We got it from 4 points, 2 on one side and 2 on another side. And that creates these two lines that create a point of intersection. They're the diagonals, basically. So I'll write that out. Any 4 points, 2 from one side of R and 2 from the opposite side, determine a convex quadrilateral whose diagonals cross once inside R. So that diagonal, I guess I could, or that quadrilateral is what I should be saying. I could draw in like that. And as you can see, the diagonals, which are in red, cross once and therefore make a point of intersection. So that point of intersection is, I think, what we are searching for. And there, in particular, how many of those? Okay. So from this side, there's 6 points. From those, you need to choose 2, just as we did. We chose this guy and this guy. And then similarly from this side, there's 8. From those, you need to choose 2, just how I chose those 2. And then multiply them. So this would give me 15 times 28, which is 420. And that, 420, is the answer to this question.